This presentation is about an historical investment that Novo Nordisk is doing. They are scaling up in a global range of formulation and filling facilities, and it's a very big project. Novo Nordisk has a long history of doing automation, as all companies probably have, but we have been I just need to finish the part about Novo Nordisk, I think. I'm working in Novo Nordisk engineering, so I'm not working on the shop floor. I'm not producing anything. I'm just an engineer assisting Novo Nordisk whenever they have a need. Currently, the most need they have is for consultants, so we consult them in buying equipment. When they are less busy, sometimes we even are allowed to be integrators, but not now. So my task here and what I'm going to talk about today is also being a consultant for Novo Nordisk, buying in new equipment and some experiences I had there. We have to buy a lot. And when I say a lot, I mean a lot. So we designed one factory, and this factory, we want to build multiple of this factory all over the world. And for that, we need a lot of equipment. And actually, we're going to build so much, so we cannot even, for example, buy all the autoclaves from one company. They cannot deliver that. So we need to find a way to buy standard equipment from multiple vendors and fit them into our strategy. Yeah. And the approach would be to buy these standard equipment, not to moderize them in any way, but just use them out of the box. That would be the philosophy to follow. So, yeah, then when we start this journey, of course we use the vendors that we know already, but we also use vendors that we haven't used for many years. And that is also where COPA-DATA comes into the picture, but we have also met in other contexts. But what happens is that when these vendors, we want to buy these standard equipment, it often crashes a bit with our IT standards. So we have quite a mature IT setup with a lot of services already in silos, as we learned earlier today. But we do have that, and they are actually really well functioning and really mature. So what happens when we need to do these workarounds with this equipment is that we have to ask the machine builders to rebuild some of the automation to actually fit into our IT system. And some are easier than others, but it's always a negotiation and discussion and how far can we push these machine builders. So, yeah, I said legacy strategies, and we actually saw the slide earlier today with the PLCs and the HMI on each piece of a machine on a line. Precise the picture that I sometimes see, because it probably works, I guess. But we are also having the IT strategy and the IT services that actually support the gold that we saw on that slide. So we can actually provide all these IT services that is needed to do that. But we need our vendors and our machine builders to follow up and take a part of that. And of course, if you're using old SCADA systems, old versions that doesn't have the features that we need, then you would have to do some custom code and so on to do that. Be used to that. We will buy custom code from vendors to integrate to our IT security, into our IT services. But This customization, it has a price. It has a really high price for us because as it can seem very flexible at the time when you're implementing it and you get everything to work, it just becomes a burden over time because over time, every time we want to maintain the OS system or we want to patch the OS, we want to upgrade the IT, OT systems we are running, it becomes a risk because we need to take into consideration of this customization will work every time. We need to test it and document and so on and so on. Yes, so I want to shift a little bit over to some of the things that we actually go for because we are producing medicine. We don't care about automation layers or whatever, right? It just has to work and be easy to maintain and be compliant. Then we are happy, right? So we will definitely always focus on compliance and data integrity. That is the most important to us. The data, that's our goal in our documentation. And when we are focusing on that, back in the old days, I would say, we were just looking at this software and it said it was part 11 ready, go for it. Then we were ready to do some automation, right? But that has also shifted a lot. We are doing science and risk-based validation today. So that means that we have based on the process and the equipment and everything, we do have defined risk that we need to mitigate. So that becomes quite challenging when we have machine builders that are used to a URS with some requirements, and we are now talking risk all the time, right? So it becomes, the compliance part becomes quite urgent. So, and I will return to that later. We also have the compliance with the user management and so forth. Actually, I try to always narrow it down to 3 things. The ER, the electronic records, the ES, the electronic signatures and user management, and then the IT security. And the IT security is actually not a critical requirement. We can produce medicine even if we don't fulfill all of these. But not the data, not the electronic records and the electronic signatures. So the data integrity is the most important thing. And we have a very strong governance of that all over Novo Nordisk. So that is something that is the same all over. So then I said I didn't care about the OT layer or anything, but I do because otherwise I cannot comply with these things. Because if I don't have OT systems up to date, I don't have the latest versions, I cannot update the OS, I cannot patch the OS. I will then, the OT systems become a security risk, and then we cannot use it for production. It also stops the integration of the modern MES system and ERP systems. We also use PASX, and they come with new versions, with new features, and we want to utilize that. And it's very annoying if we have to wait for all the OT systems to get upgraded before we can do that. So we're just going to do some custom code, right? But that is, of course, not a very good strategy. So keeping the SCADA platforms up to date is essential both for the security and the functionality. So, yeah, so a few years ago, I came across Zenon, and I was like, the first time I saw it, and I said, oh, no. And then I went back to one of my colleagues who have been working with it before in another company, and said, yeah, it's really, you should definitely look into it. And then I actually realized that Zenon actually fits really well into our architecture. So all the Active Directory, the SQL, the PASX system, Octoplant for configuration management, which has not been mentioned here at all, I think. It's very valuable for us. It actually lowers the operations cost a lot, because if we didn't have these services, there will be a lot of manual operations that we needed to maintain, and that will cause downtime on the systems and so on. So I was really surprised and started to do a lot of investigation into Zenon and also pushing our suppliers to do better and integrating more of the standard features from Zenon instead of doing custom code. And that has been a journey, really interesting and also very, very nice to see that the machine builders actually also develop and agree to do some of this stuff. That has been really, really nice. So maybe I will just return a little bit to the compliance part and so on. So we have this, instead of we have traditional validation with a URS, we have this science and risk-based approach. That means that a scientist or a SME actually looks at the process and the equipment, and then they define the risks that is for this system. And this should be an easier way to mitigate the low-hanging fruit rather than just doing the same validation every time. So based on that, we have some risks, and these risks is very academic. And if I send these risks out to my machine builders, I guess they think I'm crazier than usual. So what we do is that we take the relevant risk, the risk that is relevant for the equipment that we will buy, and then we will write an engineering specification. And this engineering specification will include some design inputs, so not requirement, but inputs to how we would like it to be. And that one is also quite generic because it's not specific written for Zenon or any other OT enabler or anything. It's just a generic document. So using that document towards our machine builders is also sometimes very a big hustle to agree on what it actually means. So what I did together with COPA-DATA was that we took this engineering specification and we made one specifically for Zenon, and it was not just a copy of the Zenon help file or anything. We actually looked at Zenon is quite agile, so we looked at which capabilities in Zenon would actually fit into our IT services, and then we took those parts and wrote this guide for the vendors, for the machine builders, on how they should utilize Zenon in Novo Nordisk. And at least we liked it. I also hope that the suppliers to some extent could use it, but at least it was a very good basic for the discussions, and also being able to say yes and no, because it's still design inputs, right? So the vendor can say, no, I cannot deliver that. And then the project management actually also understood what they wouldn't get, right? So it was beneficial for several things. Yeah. So Giuseppe asked me to take a few examples from this guideline, and I think one of the most important ones was to utilize the data storage from Zenon, because if machine builders invent their own data storage and so on, then we will set very high requirements for documentation of that. How did you ensure store and forward? What does this column in the database mean, and so on? Everything needs to be explained. Because if we can misunderstand the data, then there is also an option that we actually release some products based on misunderstandings, and that is worst case scenario. So utilizing the data storage from COPA-DATA and Zenon actually meant that a lot of the documentation was already provided from COPA-DATA, and then the machine builders only had to deliver the documentation on how the process actually worked and how they stored and which data they actually stored for that. So I think that is absolutely the biggest advantage that we had from that. Another thing is actually the architecture of a zenon, how it was possible, and back to the drawing that we saw earlier today with the many PLCs and HMI for each machine on the line. With zenon, we could actually put the applications into one virtual machine and have a terminal server used for the clients, and then have the thin manager on top of that. So that was really nice as well, and I think that really removed a huge footprint of the server layer onto our solutions. Yeah, and I think in the ideal world that we had and discussed, we didn't get 100%, but we did move a little bit. Not a little bit, I actually think our suppliers moved a lot, and so it was a really nice cooperation we had with COPA-DATA on that. So I've been working with SCADA system, also with SCADA system for many years, and why I think that the zenon stands out. I actually think they have a very strong roadmap. Actually, we haven't even looked into MTP yet, so we are going to start that up now. So they are ahead of us, really nice. They listen to what we say, so when we have requests, it's been taken very seriously. When our machine builders had issues implementing the things we have requested from them, we got really, really good support. So that was very nice to see. And one of the things I really, really like is that you have these strategic partnerships. For example, in our case with COPA and Octoplant, but you also have other partnerships, and I think that is really forward-thinking, and that will bring value across the ecosystem all over our facilities. That we can trust these implementations you have, and you have aligned with the other companies on this. That is really nice.